All right, subtracting rational expressions is similar to adding in that you need to factor your denominators and get a common one. Now, you're going to do top minus top instead of top plus top because it's subtraction, so obviously you minus it. And you're still going to expand and simplify and maybe even refactor the top. The real difference here is that you're going to have to subtract everything that's on the top here. That's going to be minusing x and also minusing 3. I'll show you what I mean in just a second. But first, let's take a look at the denominators. X plus 2 can't be further factored, and x plus 4 has nothing that goes into both of those numbers, so it can't be further factored either. So we need to get a common denominator. That's noting that there's no x plus 4 in the denominator of this fraction, so we need to multiply the top and bottom of this fraction by that extra x plus 4. There we go. By multiplying the top and bottom of the fraction by the same thing, we're not affecting the value because the x plus 4s would cancel, even though we don't actually want them to here. In this denominator, we're missing an extra factor of x plus 2, so we have to multiply the top and bottom by that. Now the bottom of both fractions is x plus 2 times x plus 4. It is here as well, but they're multiplied in a different order. That's totally fine. And the next line is going to be top minus top, all in one fraction. I'm going to write it out here because we're multiplying binomials. That's minus, and the other top times x plus 2. That is all over, as in we've turned two fractions into a single large fraction, where the new bottom is whatever the bottom that was common to both was. That's x plus 2 and x plus 4. Now this is technically subtracted from each other, but I want to show you how we expand and simplify this. I'm going to use FOIL, at least that's what we call it here in Canada, to multiply x times x, x times 4, 1 times x, 1 times 4. That's x squared plus 4x plus x plus 4, and minus, I'm going to keep this product in brackets just to emphasize that we're subtracting the product. And remember, in terms of order of operations, multiplication comes before subtraction. I get x squared plus 2x plus 3x plus 6. And it's still all over that common denominator of x plus 2 and x plus 4. Now, when I distribute the negative to this, well, the first 4 terms don't change. In fact, I'm going to collect these and make that x squared plus 5x plus 4. And I'm going to subtract everything that's in brackets here. That's minus x squared, minus 2x, and minus 3x, which gives me minus 5x. And I'm going to minus 6. Now take a look at what's happened. Everything that was after the minus sign had its sign flipped because we were subtracting it. The same bottom of x plus 2 and x plus 4 continues. I should put equal signs at the beginning of every line. And then x squared minus x squared cancel. Oh, 5x minus 5x also cancel. I got lucky there. That won't always happen. And I have 4 minus 6, which gives me negative 2 over. That's x plus 2 and x plus 4. This is the simplified rational expression. I should just state my restrictions. Here x can't have been negative 2 because that would have made that factor 0. And x can't be negative 4 because it would have made that factor 0 as well. So I have my simplified rational expression, and there are 2 restrictions here, and all it took was getting the common denominator and doing top minus top. Cool? Let's do it again. Oh yeah. Now we have to factor the bottoms first so that we know what we have to multiply each thing by to get a common denominator. This factors, I need 2 numbers that multiply to negative 3 and add to negative 2. It factors to x minus 3 times x plus 1. This next one factors by difference of squares, x minus 1, x plus 1. And this one requires 2 numbers that multiply to 3 and add to negative 4. That's x minus 3 and x minus 1. Now to get a common denominator, we need to take a look at each one and see if it's missing from all the others. What I mean is there's an x minus 3 in the denominator here that is here, but it is missing from this one. So I have to multiply the top and bottom of this by an extra x minus 3. This x plus 1 is here and here, but it is missing from the third one. So I have to multiply the top and bottom by that extra x plus 1. The x minus 1 is here and there, but is missing from this one. So I need to multiply the top and bottom of this one by x minus 1. Whew. X plus 1 is in all of them now, x minus 3 is in all of them, and x minus 1 is in all of them. And there's nothing extra, so we're actually done. Now it just takes us doing top, well, plus top minus another top here. And we can combine these all into a single fraction. Would you like to do it with me? I'm going to write 4 times x minus 1 plus x times x minus 3 minus 3 times x plus 1. Look at all that. And my bottom, x minus 3, x plus 1, x minus 1. I hope that's not intimidating for you. In fact, the top is just distributing each coefficient through the brackets, and then we're going to collect like terms. Here we've got 4x minus 4. Positive x times each of these gives me plus x squared and a minus 3x. Negative 3 times each of these gives me negative 3x again. And negative 3 minus, or times positive 1 is an extra minus 3. Bottom stays the same, x minus 3, x plus 1, x minus 1. I like keeping my bottom factored, just in case my final answer is also factorable, then maybe I can cancel stuff. I'm going to collect my like terms. I have an x squared, 4x, minus 3x is 1x, minus another 3x is minus 1x. And negative 4 with an extra negative 3 is minus 7. That's not going to factor anymore because there's no numbers that multiply to negative 7 and add to negative 1. If you don't know how to factor quadratics, you're going to have a bad time. I don't know if I ever told you that. This is my simplified rational expression, and I just have to state my restrictions. X can't be positive 3, or negative 1, or positive 1. There you go. That's it. That one actually felt like even less work than the last one, even though there were 3 things to do. Go figure. Cool. Again, factor the bottoms, get the common denominator, top plus top minus bottom in this case, expand and simplify. Donezo. Allons-y encore une fois. That's French for est it. Factor the top and bottom as much as possible. 4 over 3 times x minus 3, because a common 3 can get pulled out of both of those. I like showing this one where you have 3 minus x. This one actually factors, if you consider this to be, there goes my cat. If you consider this to be negative x plus 3, you can factor it to become negative 1 times x minus 3. I'll show you what that means. I convert the plus to minus, keep the top the same, and I flip those two's order. The reason that works is that 3 minus x is the same as negative x plus 3, and I can factor a negative 1 out of both of those. We like having an x out front anyways, right? And the negative 1 builds in to convert plus into minus. Just a little trick for you. I know some high school teachers really like including that, so I put it there. This bottom isn't further factorable, so I leave it as is. Now, what am I missing and where? Well, there's a 3 on bottom here that isn't here or here. So I'm going to have to multiply the top and bottom by an extra 3 here, and the top and bottom by an extra 3 here. I have an x minus 3 that I also have here, but I'm missing here, so I need to multiply x minus 3 into both of those. And I have an x plus 3 here that is not in either of those. Lord have mercy. We're going to have to multiply the top and bottom of this by x plus 3 and the top and bottom of this by x plus 3. This can be a lot of work to get a common denominator, but what are you going to do? Now, my top minus top plus bottom here becomes 4 times x plus 3 minus, now I have 3 times x plus 3, which I can rewrite as 3x times x plus 3. And I have 33 here, which I can multiply by the x minus 3 eventually. My bottom, which I should have checked to make sure was the same everywhere. 3, 3, 3, x minus 3, x minus 3, x minus 3, x plus 3, x plus 3, x plus 3. Yes, let's do it. I have my 3, my x minus 3, and my x plus 3. There we go. This is technically correct, but we should expand and simplify the top just in case. Let's go. 4x plus 12. 3x, negative 3x times x and times plus 3 is minus 3x squared minus 9x. 33 times all of this is plus 33x and minus 99. Whew. Bottom stays factored just in case the top factors once we're done. Let's collect like terms. I only have one thing with x squared in it. That's negative 3x squared. 4x plus 30. Oh boy, 4x minus 9x is negative 5. Plus 33 is plus 28x. And I have 12 minus 99, which gives me negative 87. That is, I don't think that's going to factor. I can't think of two numbers that multiply to, what, 261 and add to 28? Whatever. 3x minus 3, x plus 3, and since I'm agreeing that it's pretty much as far as I can go, I should state restrictions. X cannot be positive 3 for this, or negative 3 for that. There we go. The final answer here doesn't matter so much as your understanding that you need to factor the bottoms, get a common denominator, do top plus top minus bottom or whatever it says to do, expand and simplify. And that's it. These are all like easy tasks, but to do them all at once can get a little complicated and intimidating. But nothing scares you, am I right? Nothing scares you either, does it, Luna? Take care, and best of luck to you.